Sir Professor Patel from LJIET Institute of Engineering and Technology, Automobile Engineering Department. So in today's lecture we will learn about the first chapter, that is aerodynamics. So in aerodynamics the air is come into the picture and how the air is going to react while the change of the shape of my overall vehicle. So in today's lecture we will talk about main two topics. The first one is about the introduction of aerodynamics. So in this lecture, in this topic you will find that the aerodynamics is the deal when the vehicle is in motion condition, and the second topic, that is about mechanics of airflow around a vehicle, in which we will see the how pressure and velocity are going to change at a different distance. So let us begin with the first chapter, first topic, that is introduction of aerodynamics. So in this particular topic there are several keywords you have to check or you have to keep in mind during the preparation of that topic. So here are the different keywords like drag, lift, forces, moments, etc. So in this particular topic we will talk about these different kind of keywords. So basically the aerodynamics is the all about the air, but what we will see, while my vehicle is in moving condition, or like say if the vehicle speed is about 150 or 200 km per hour, so at that time due to the air effect overall the vehicle performance is going to change, or it is directly or indirectly impact on my fuel economy, also handling, noise, vibration and harshness. So it is the reaction or interaction between the air and vehicle. Also the aerodynamics arise from two different parameters, that are drag and viscous friction. Drag you will see in the next lecture, and second is about the viscous friction. So the friction between the surface of car body and air. So here one example is given to you, that is for wind tunnel testing, and in wind tunnel testing the car is placed and the smoke is blow towards my car, and how that smoke is going to affect due to the overall vehicle shape. So that is the mention over here. Moving further, several examples are there which shows the effect of the overall aerodynamics. So in this animation you can see it is the famous building of Burj Khalifa in Dubai, and you will find it in desert at which you will find maximum wind speed, and due to that wind speed how this structure is going to react. So this is about the analysis at which place the wind speed is minimum, and at which speed at which portion the wind speed is maximum. So this is the actual analysis while we are blowing some air to particular that building, and at different places the wind is changed, the speed of the wind is changed. Let's say if you are standing on 100th floor, and at that balcony you will find the maximum pressure, and being a civil engineer you have to solution about that question, that at that high pressure people cannot stand properly in the balcony. So for that different changes are going to required in that structure to minimize the pressure. So these kind of deals are going to talked in our lectures. So moving further to the next example, that is about the wind tunnel testing. So this is all about my car and planes in which wind tunnel testings are required. So here you can see the car standing steadily and the air is blowing over it, and due to its shape how the streamlines of air are going to affect that we have to find out. So this is a sports car. So according to it is well behaved with the respect of air. While we are talking about the second type of vehicle, that is truck, and in the truck what we will see, you will find there are lots of changes in the aerodynamics, or we can say the flow of air. Like here you will find number of vortices, and the pressure differences at several points are changed. So we have to keep in mind, to deal with maximum speed I have to optimize my different shapes of the vehicle or different components of the vehicle to minimize the drag or to minimize the air resistance. Moving further, let us talk about the second topic, that is mechanics of airflow around a vehicle, in which we have to see the velocity, pressure, different streamlines of air, boundary layers condition. So according to the Bernoulli's equation, we will find how the mechanics of airflow is going to happen with my particular vehicle's body. So for incompressible flow, we count air as an incompressible flow, and we all know that static pressure and dynamic pressure is total of my pressure. So we can say that PS plus half rho v square is equal to total pressure. In this term, you will find the rho is the density of air and v is the velocity of air. So the velocity of air is relative to the car, not with the speed of my car. So that is the relative speed of my car. Moving further, let us say the sphere is placed in the airstream. So you will find at starting the pressure of the air is normal. So we can say the at atmospheric pressure. Now the nearest part of the sphere you will find the maximum pressure, and at the surface of that sphere you will find velocity is 0 and the pressure is maximum. Above the pressure you will find that pressure is going to decrease. So in the second figure you can see that in center there is Cp, pressure value, coefficient of pressure, drag, that is 1, above is 0, and the top one is the 3, at which you will find the maximum pressure on the surface of the sphere. Now let us say the concept of boundary layer. So at which you can see that the wind is coming, so you will find the velocity, and that is denoted as u infinity. So at that time no pressure is there. Some surface like the car body is there, and due to that surface what will happen, the velocity are going to reduce, and due to that reduced velocity what will happen, the boundary layer condition is going to generate, and from the below level to the top level the boundary layer is going to increase, and after some time that boundary layer is going to eliminate. So this about my boundary layer concept, that laminar flow is there, transition flow is there, and third one is the turbulent flow is there. So that boundary layer concept we are going to talk in our cars portion, at which you will find the top portion. This is the top portion of my car, at which you will find certain boundary layer. You can see the height of that boundary layer is delta provided here, and after some time you will find the overall curve is going to reduce, and due to that reduced curve what will happen, at this point, you can see this point, you will find reverse pressure, or we can say the adverse pressure effect is going to produce, and due to that adverse effect vortices are going to happen, and due to that vortices the pressure difference is going to generated. So these are the overall concept about my car while my vehicle is in moving condition. Also you will find one separation point at which velocity is 0, and after that point the negative velocity of pressure is going to generate. So this is all about the vehicle. Moving further, if we are talking about the vortices, so here you can see one diagram when the sphere is placed and the airflow comes from the front side, and due to that vortices you will find ineffective flow of air while passing through over the sphere. So due to that vortices the pressure difference are going to change, and these kind of effect is going to negligible in my sports car, where I am talking about the speed of my car or aeroplane above 150-200 km/h speed. So that is all about vortices, how aerodynamics are going to affect my overall car body and all, and how different shapes are going to change with respect to the airflow. So this is all about the first topic. Thank you.